this video, we want to introduce the idea of a logarithm and define what a logarithm is. But first, it's helpful to step back and think about exponents instead, because logarithms are very closely related to exponents, and exponents are something that we already know a lot about. So if we think about an exponent, the question it answers, for example, is, what do I get when I raise 2 to the third power? So when I have an expression like this, I have 2 to the third power, where the base is 2 and the exponent is 3, and I want to find the result. Remember that exponents tell us how many times to multiply the base by itself. So because the exponent is 3, it tells us multiply 2 by itself 3 times. In other words, this is equal to 2 times 2 times 2, and we know that 2 times 2 times 2 is equal to 8, so we could fill in this result. Logarithms, on the other hand, help us answer a different question. For example, to what exponent do I raise 2 in order to get the result of 8? And here's what that looks like. We have 2 raised to an unknown exponent when we already know that the result is 8. So looking at exponents here, we have the base, we have the exponent, what we're missing is the result. But when we're talking about logarithms, we have the base, we have the result, we're missing the exponent. Logarithms are what allow us to solve this problem and identify that this value here is actually 3. Now this is an easy problem, and we just looked at the associated example here, so we knew this was 3. But a lot of times the problems will be more complicated than this. We won't simply be able to fill in the box just by visually looking at the equation and knowing offhand that 2 raised to the third power is 8. Logarithms are going to allow us to solve more complicated examples like these ones. So understanding that logarithms allow us to answer the question, what is the exponent, and exponents allow us to answer the question, what is the result, how do we actually use a logarithm to solve this exponential equation? Well, to change this into a log equation, we write it this way. We say log, which is short for logarithm, to the base 2, so we write 2 as a little subscript, a small number that sits just beneath this log notation. So log base 2 of 8 is equal to 3. So this log equation represents exactly the same thing as this exponential equation, 2 to the third is equal to 8. If we're reading this log equation, it's asking us here on the left-hand side, to what power do I have to raise this base of 2 in order to get a result of 8? And then the result of that question, or the answer to that question, is 3. In other words, this is saying I have to raise 2 to the third power in order to get a result of 8. Keep in mind also that whether we have an exponential equation like this one or a logarithmic equation like this one, both equations always include the base, the argument, and the exponent. So we already know here that in the exponential equation, we have the exponent of 3, and we can identify that same exponent here in the logarithmic equation. We also know, and this is probably the one that makes it easiest to remember, that the base here is 2. So this is the base 2 raised to the exponent of 3, in the same way that we have log base 2 with the 2 down here. So this is the base in the exponential version of the equation, and this is the base in the logarithmic version of the equation. And then the argument of the logarithm is always this number right here. So this is called the argument of the logarithm, and we see that argument over here on the other side of this exponential equation. So we call this the argument. We call this the exponent. And we call this the base. With that in mind, we usually read this logarithmic equation as log base 2 of 8 is 3, or the log of 8 with base 2 is equal to 3, or maybe even the base 2 log of 8 is 3. The other thing that we want to keep in mind here is that I wrote this logarithmic equation without parentheses, but a lot of times you'll see it written this way. You'll see log base 2 of 8 is equal to 3, with parentheses around the argument. These parentheses do not indicate multiplication. They indicate that 8 is the argument of the logarithmic function. So this is not log multiplied by 8 or log base 2 multiplied by 8. This is log base 2 of 8 is equal to 3. This should be a little familiar to us, this idea of the argument, because we've already talked about functions where we have the idea f of x is equal to some function x squared. This f of x notation indicates a function, and this is not f multiplied by x. X is the argument of the function f, and so we read that as f of x in the same way that we read the log base 2 of 8 is 3. So in neither of these cases do we have multiplication just because we have parentheses. The parentheses indicate that these values are the argument of the log function or the argument of the function f. Now we've already looked at converting between exponential equations and logarithmic equations, and so we want to formalize that into what we call the general log rule. And the general log rule tells us that if we're given an exponential equation where we have the base a raised to the power of x is equal to the argument y, then that is equivalent to saying log base a of the argument y is equal to the exponent x, and vice versa. And the vice versa tells us that even if we're given the exponential equation, we can transform this into the logarithmic equation. And if we're given the logarithmic equation, we can transform it into the exponential version of the same thing. So we can go back and forth between these two depending on where we're starting and what we're trying to solve for. So let's look at a couple of examples of that. First, let's say we're given the exponential equation 5 squared is equal to 25. We know from exponents that this is true because 5 squared is 5 times 5, and 5 times 5 is 25. So we understand this as an exponential equation. 5 squared is equal to 25. We want to use the general log rule to convert this over to a logarithmic equation. We can always use color to help us translate the exponential equation to the logarithmic equation, or vice versa. So let's identify quickly here that the base a, we'll just box that in blue, and the exponent 2 will box in green, and the argument y will box in red. And then when we want to convert that to a logarithmic expression, we'll just write this out matching up our colors. So we have log the base of a, which we know is 5, so we'll write the base 5. The argument will be y, what comes from the right-hand side of the exponential equation, which in this case is 25, will be equal to x, which is the exponent, which we know is 2. So 5 squared equals 25 as an exponential equation can be rewritten as log base 5 of 25 is equal to 2. And this makes sense because remember that the logarithm says, to what exponent do we have to raise 5 in order to get 25? And we know that we have to raise 5 to the power of 2, the result over here, in order to get to 25. Now if we go the other way, if we start with something like log base 2 of 8 is equal to x, again we can go ahead and write these here in color. We know we have the base, the argument, and the exponent. So if we now want to write this in exponential form, we take the base, which we know is 2, so we'll go ahead and write the base here as 2, raised to the exponent, which we know is x, and then that's going to be set equal to the argument y, which we know is 8. So writing log base 2 of 8 equals x in exponential form gives us 2 to the x equals 8. And again, that makes sense because the logarithmic equation is asking, to what power do we have to raise 2 in order to get 8? And the exponential version is also asking, to what value do we have to raise 2 in order to get 8? Because here's this unknown value for the exponent, so that's the value we're trying to solve for. So these first two equations are equivalent, and these second two equations are equivalent. They've just been converted to one form and the other using the general log rule. In this second set of equations here, the value of the exponent was unknown. But keep in mind that whether it's the exponent that's unknown, the base that's unknown, or the argument that's unknown, we can still use the general log rule to convert back and forth between exponential form and logarithmic form. All we have to do is remember this pattern where the base of the exponential function becomes the base on the logarithm, the exponent on the exponential function becomes the result of the log equation, and the result of the exponential equation, the argument, becomes the argument of the log function.